What up, athletes? Whoop, whoop. All right, let's get into this. This is 10.5. I will find fractional distances on the number line. All right, take a minute, do your warm-up. You know the drill. I'm out of coffee, so I'm going to sip water. Excuse me. Ready, set, go. What a dream. Okay, I'm assuming you can always pause it if you get time. All right, let's take a look at this. We're supposed to find out and identify each segment that measures less than 5 units, 5 units exactly, or more than 5 units. Okay, so let's look at AB is right here. That is 1, 2, 3, 4 units, right? So we're going to say less than 5, okay? CD, where are you at? CD right here. All right, for this I'm going to look at the triangle. Create a right triangle here. Hypotenuse is the longest leg, and this leg alone is 1, 2, 3, 4, 5, 6, 7. If that's 7, guys, the diagonal's longer. CD is greater than 5 units. All right, EF. Where's EF? EF is right here. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that again is greater than 5 units. GH is 1, 2, 3, 4, 5 units. IJ is a harder one. Check this out. This is 1, 2, 3. 1, 2, 3, 4. So it could be that that's 5 or less than or greater. I don't know. Let's find out. Here's what I know. This is my hypotenuse, so it's C, and I know that A squared, remember Pythagorean theorem, plus B squared equals C squared. So my legs are 3 and 4, so that's going to be 3 squared plus 4 squared equals C squared. 3 squared is 9 plus 16, and that's going to be, what, 25 equals C squared? Well, to get to C, I got to square root both sides. That does a square. What's the square root of 25? It equals 5. So this equals. Okay, well, let's keep going. We're going to talk about locating a point. Oh, by the way, so that's equal 5, right? Locating a point at fractional distances. Fractional distances on a number line. Okay, first of all, let's not make this complicated. It's going to look complicated, then I'm going to simplify it if that makes any sense whatsoever. Okay, let's say I want to find some point P on segment CD right here, and I want to find it some distance A over B, okay, in between. All right, here's how I'm going to do it. First of all, I need to find the total distance. The total distance I can find by just doing what? X2 minus X1. Boom. I'm going to get out my highlighters here because they kind of are going to help us here. So I've got my X2 minus X1, that's my distance. I'm going to have my fractional distance, and we'll start there for now. Okay, first things first. This distance right here, if I find the overall distance before, this point P is going to be A over B times that X2 minus X1. That's going to get me this overall distance right here. Okay? So if I color code that, I just like to color code everything on this. It helps. Fortunately, my ink smudges, so it gets on my highlighter, but we'll do our best here. Excuse me. All right. And if I want to find that exact location of that point P, I first have to take whatever this distance is, and I have to add it to my starting point right here, okay? So if I take x1 and I add to it that fraction times the overall distance, I will end up with my point P, okay? That's how this works. If I color code this, boom. I do this because I'm going to color code it in a second as we calculate an actual problem. And I know this looks a little confusing. Just bear with me. It will all make sense in the end. It looks harder than it actually is. Go ahead and write this down for now. Okay, so all we're saying is here is we have some start point. We want to go a fractional distance to find the exact value of that point. I'm going to take the overall distance, multiply it by that fraction, and then add it to what I started at. And that's going to get me my number. So let's look down here at A. I want to find a point B on AC. That is 1/4 the distance. Okay? So to do this, first of all, let's identify our parts. My A over B equals 1/4. Boom. Color coding is coming in clutch right now. A little piece of paper, I smudged this on to get rid of it. And then my x1 equals what? -5. We see it right here. And my x2 equals 7. Which again we see right here. It's those endpoints, right? Smudge. What does that mean for me? Well, if I plug it into this, my x1 serves two purposes. First of all, if I plug it just into this overall formula, guys, I'm going to say, all right, -5 plus my fraction, which is 1/4, times 7 minus -5. Notice those two negatives are going to make a positive. That's on purpose. Okay? And let's just color code everything, right? This is my start value, which I had up here. We know I have my fraction I'm multiplying times everything to get that fractional distance. And this is the overall distance between -5 and 7, which I were to count that, guys, watch this. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What's 7 plus 5? It's 12. So I end up with what? -5 plus 1/4 times 12, which what is that? That's going to end up being 1/4 times 12. 4 goes into 4 once, goes into 12 3 times. I have that's just -5 plus 3, which equals -2. So the point that is 1/4 the distance should be at -2. Okay? And here's what I want you to know. Watch this. This goes 1, 2, 3, right? So there's 3 there. If I go 1, 2, 3, it's 3 in between there. 1, 2, 3, 3 in between there, and 1, 2, 3 finishes me here. If I were to separate this into 4 parts, 1/4, notice, is exactly on point B. That's what we're finding right here, guys. Now, this is for the formula-oriented people. How I'm really going to do this, guys, at least for me, okay? So I want to now find x, which is 2/3 the distance from A to E. So first things first, guys, I'm just going to figure out this distance. And you can count it or subtract to get it. But I'm going to say, hey, AE equals what? 7 minus -2, which is just a plus. So that equals 9. Okay? All right. And I want to find 2/3 of 9. 3 goes into it once. 3 goes into 9 3 times. I'm left with 2 times 3, which equals 6. Perfect. Now I'm going to take that, and I'm going to say, okay, we started at -2. -2 plus 6 equals 4. That's my final point. 4 right here. That is where x is. That's how I'm actually going to figure this out, guys. I just kind of logic it out. I find the distance. And if you don't want to subtract, count. 1, 2, 3. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? It's 9 in between. That's what I got. And if I were to separate this into 3 parts, 1, 2, 3, they both end up being parts of 3. 3. Notice that x is at that 2/3 part. Okay? Perfect. Life applications right here. Let's do it, guys. Biking. Julio is biking from his house to the library, school, and the library is 4 blocks east of the school. If he stops to rest 1/3 of the distance from his house to the library, at what point does he stop? Okay. Let's figure it out. What's my distance? It's going to be this 4 minus 8. Right? It's the library from his house. And what's 4 minus, oh, I'm sorry, 4 minus negative. I want to go 1/3, so I'm going to find 1/3 times 12, right? I can always put that over 1 if that helps. 3 goes in there once, goes in there 4 times. 1 times 4 is 4, so that is 4. So the point I'm going to, gets a word answer, he stops at -4. Awesome. Positive needs, let's move on. Now we're going to ask ourselves, sheet notes to the left here. I do this ahead of time at least once, sometimes even more. Because I write these, I want to make sure I don't have errors in the lesson. Ooh, wrong button. Okay, so we are going to talk about locating a point. Locating a point on a number line when given a ratio. Do me a favor, guys, X this out. You don't need it. A ratio is something like n to m, where if I were to rewrite this as a fraction, it would be n over n plus m. What do I mean? If I have a ratio of 5 to 7, right? That means it's the same as the fraction 5 over 5 plus 7, which just equals 5 over 12. Why? I'm saying if I cut something into 12 parts, I want the left half to our parts. In this case right here, let's look at this, P. This is like saying, hey, I've got 1, 2, 3, 4, 5. So over here I have 5. Over here I have 1, 2, 3, 4, 5, 6, 7. Boom, 7. Look at that. Works out just like I showed you. And altogether there's a distance of 12. So what we're going to do is we're going to take ratios and just turn them into fraction, guys. That's what I do. It's what we're going to do to move forward, okay? So let's do this into steps. Step 1. Turn the ratio into a fraction. Like magic, pause the video, write the other steps down. It goes from turn the ratio into a fraction, apply the fraction times the distance, add results to x1 to find your point. So let's do this right here. Find B on AC such that the ratio of AB to BC is 3 to 4. Again, step 1. 3 over distance between here. Oh, and the distance, or I'm just going to put AC equals what? 7 minus -5. We've had that already. That's 12. Step 2, let's multiply those numbers. 3/7 times 12. It's going to look complicated for a sec. That equals, well, straight across, 36/7. Oh no, what shall we do? Step 3, add that to x1, -5 plus 36/7. Well, -5, if I were to turn that into 7, 7 times -5 is -35. So this would end up being -35 over 7 plus 36 over 7, which equals 1/7. That's my point. So let's go to 1/7. It's about right here-ish. And that would be my point. What, B? Boom! Just like that, y'all. Okay, I want you to try this. Take a minute. Take a breath. Go ahead and do it. Ready, set, ready, set, ready, set, go. Okay, I'm assuming you paused this. Okay, I'm assuming you paused it. We're good to go. What is the coordinate of x on AE such that the ratio of AX to XE is 1 to 2? Well, again, step 1. We're going to have 1 over 1 plus 2, right? Which equals 1 every 2, so that's really 7 right there. So we are going to have AE equal 7 minus -8, which is a plus. So that equals 15. Boom. Step 2, let's multiply those two numbers together. 1/3 times 15. 3 goes in 3 once, goes in 5 times. We're going to add that to -10. -10 plus 5 equals -5. and booze. Let's go to -5 right here in between, and that is our point X. Awesome. Let's go ahead and move on. Take a minute, read this, give it a shot. Okay. Jorge is traveling 2,563 miles from New York City to San Francisco by car. He plans on stopping for gas when the ratio of the distance he has already traveled to the distance he still has to travel is 2 to 5. How far has Jorge traveled when he stops for gas? Okay. Well, since we're going from New York, we're going this way, right? Boom. Here's what I know, guys. Couple things. One, this is already separated into 1, 2, 3, 4, 5, 6, 7 parts. So we're going to stop for gas right here at the 2/7 mark. Okay. How do I know it's 2/7? By the way, because it's 2 over 2 plus 5 equals 2/7, right? That's step 1. Okay. We already have the distance. The distance is 2,563 miles. And since we're starting from 0 to find the distance traveled, we're just going to multiply 2/7 times 2,563 miles. Just let me get my handy dandy calculator out. 2 times 2,563 equals divided by 7. Boom. And we have about 732 miles. So that's going to be about 732 miles. And we would say Jorge travels approximately 732, oh, sorry, you can't see that very well, miles before stopping for gas. All right, that is finding fractional distances on a number line. With that said, peace out.